Okay, everybody, so next we're going to talk about solving radical, not radical, exponential equations. Okay, these are going to be equations where there's something going on with some exponents here. Now, these are going to look a little different than anything you've seen before. Okay, in this case, we have a situation where I have 2 raised to the 3x plus 1 equals 2 raised to the 13. Now this is a good thing, okay? Because the key to these is we need to have a common base. And our goal is going to be to create a common base if we don't currently have one. And in this case, we do have a common base. The common base is 2, okay? Let me kind of do away with these circles here just to clean this up a little bit. When you do have a common base, what you're going to do is you're going to make an equation out of the exponents. So in this case, I can just simply do 3x plus 1 equals 13 because of the fact that the bases are the same. So now you kind of see why it's important that the bases are the same, or to create bases that are the same, because once you do, it makes a much easier equation for us. So I'm just going to solve this now as a 2-step equation. So I have 3x equals 12. I'm going to divide each side by 3, and I'm left with an x value of 4. So let's check here and see if that indeed works. If I go ahead and plug that back in, right there, I get 2 to the 3 times 4 plus 1 power equals 2 to the 13th. Well, 3 times 4 is 12, plus 1 is 13. So yeah, 2 to the 13th is equal to 2 to the 13th. So that works, and my equation, or my solution to this, would be 4. Remember, the whole goal here is going to be common bases. If I can make it happen, I need to make it happen. Second example. In this case, we do not have common bases, because my first base is a 5 and my second base is a 125. But what you want to do is, okay, once you see that one of your bases is 5, you kind of want to either grab your calculator or just kind of in your head start going through the powers of 5. 5 squared is 25. 5 to the 3rd power, well, that turns out to be 125. So what I can do here, I'm not going to change anything over here. I'm still going to keep this as 5 to the 2x minus 5. But on my other side, instead of 125, I'm going to write this as 5 to the 3rd. Okay? Now I haven't really done anything other than change the form of the number 125. 5 to the 3rd power is the same thing as 125. So now that my bases are the same, I have a base of 5 and a base of 5, now I can take those exponents and go ahead and do an equation with those. 2x minus 5 equals 3. 2-step equation. Add 5 to both sides. So I get 2x equals almost 8. Sorry about that. Divide both sides by 2, and x equals 4 again. Let's double check and make sure that this works. If I take that and I put it right there, now what I have is I have 5 to the 2 times 4 plus 5 equals 125. So I end up with 5 to the 8 plus 5 equals 125. No, I was going to say, I made a mistake here because that's not going to check out right. This is why we check our answer. Okay, because 5 to the 13th power is not 125. But the mistake I made is that this is a minus. And of course I did that on purpose just to show you why checking your answer is a good idea. Yeah. 5 to the 8 minus 5, which is 5 to the 3rd equals 125, and I already determined that 5 to the third is 125, so this checks and this works. My answer is x equals 4. Gotta find common bases, or create them if you can. So let's look at our next example. Now we have a situation where one of my bases is 49, the other base is 243. I can't multiply 49 by itself to get 243 or anything like that, so I kind of have to go backwards now. In the previous example, I went ahead and I said, okay, this 125, what times itself can give me, what number raised to a power could give me 125? So in this case, I'm looking at 49 and 243. Well, if I think about 49, I know 49 is 7 squared. So I guess the best idea would be to see if there's a way that I could do 7 to some other power that could also give me 243. And it turns out that 7 to the third power is 243. So some of this just kind of goes back to using your calculator and doing a little guessing and checking. So now here's the thing. I want to take this 49 and I'm going to rewrite that as 7 squared. Now don't forget that I already had 2x minus 3 as an exponent. So that kind of, that goes right here next to the squared, and I need to multiply that, okay? Because those exponents, you already had an exponent of 2x minus 3. Now you're kind of creating another exponent of 2. And then on the other side, 243, I'm going to rewrite as 7 to the third power, and then I already had that x that was already up there, okay? So what I have now is, I have common bases, 7 and 7. Once I have common bases, I can go ahead and I can, sort of set up an equation using those common bases. Whoa, let me undo that, because even though that was highlighted green, that turned out black. Let me see if the blue works. Nope, that doesn't work either. Okay, I'm not going to highlight that because that highlighter doesn't show up at all. So what I have here is I have 2 times 2x minus 3 equals 3 times x. Once you have common bases, you can use their exponents to set up an equation. So that leaves me with a little distributive property here, so I get 4x minus 6 equals 3x. I'm going to, you can do this either way. I'll just subtract 4x to get all my x's on one side. So I have negative 6 equals negative 1x. I would divide both sides by negative 1, and my x is going to end up being a positive 6. Okay, let's double check and make sure this works. So I'm going to have 49 to the 2 times 6 minus 3 power equals 243 to the 6th power. Well, I'll let you go ahead and put that in the calculator, but those are going to be 2 huge numbers. Bottom line is, those 2 huge numbers need to be the same thing. So 6 is our answer. Create common bases if you can. Okay. What if there's some fractions involved? Well, I want to remind you that whenever we have fractions, okay, I can always move numbers to the other part of the fraction as long as I change the sign of their exponent. In our first example, this is 49 to the first power. I can rewrite 49 to the first power if I take 49 and move it to the numerator and change that positive 1 exponent to a negative 1. Okay? Now I'm going to take this a step further, and I'm going to rewrite 49. I know 49 is the same thing as 7 squared. I'm going to write that as 7 squared. I'm actually going to undo that and do it in a different color. So 49 is 7 squared, and then we already had that -1 that was up there in that exponent. So really now what I have is 7x equals 7 to the -2 power. Okay? Another way you could look at that up here is 1 over 7. Like if you do this, and then you move 7 squared up, it becomes 7 to the -2. So now because I have common bases, I can go ahead and do an equation with my exponents, and x equals -2. Last example over here, I can take this 4 to the +1 power, move it to the numerator, and this becomes 4 to the -1 power, and I already had a -2x up there in that exponent. This is 4 to the 3rd. Okay? So this simplifies to 4 to the +2x if I do -1 times -2x equals 4 to the 3rd. I have common bases, and once I have common bases, I can do an equation with the exponents. Divide each side by 2, and I get x equals 3/2. Okay. So, the idea is this. When you have a fraction, you can simply, move the denominator to the numerator and change the sign of the exponent, and now you have a number that you can deal with and you can rewrite in order to create a common base. Okay? This is it. Ask questions as you're going through this. You got to take down the notes. You got to practice, and while we're in class, ask questions on the problems. That's part of the reason why we do this, to give you more individual time with us.